Hi, my name is Carmody, and I'm the head of dynamic scheduling and optimization at Palantir. Over the years, I've led scheduling and logistic workflows and deployments across a range of different industries. And in that time, I've seen three fundamental truths. First, planning and logistics is incredibly complex. From flight routing to crew dispatch to production scheduling, every operation has a very specific set of rules and constraints that dictate the business. Second, every operation faces disruptions. Flights get delayed, machines break down, trucks get stuck in traffic. No matter how good the original plan, something always goes off script. And third, the tools we use to re-optimize those schedules in response to those disruptions are typically static or too rigid. They can't truly reflect or adapt to the real-time realities of that moment. Let's take as an example production scheduling. Imagine that I'm the planner on a shop floor. I have to assign jobs to technicians and machines, and I have to think about technician skills, machine capacities, material requirements. I could try to assign each job manually, but with the scale and the complexity of my operations and all the rules I need to follow, it's almost impossible for me to think of every possible combination. As a result, manual scheduling often means settling for any solution rather than the most optimal for my operation. Historically, this is where we would deploy an optimization model. It takes in my resources and their constraints, and it returns an optimal solution for me. As a result, I can scale from considering a few handful of options to hundreds of thousands of combinations in mere seconds. In Foundry, I can even run this within a simulation to preview that optimized solution before I commit that back to my source system. Inevitably, however, my operations will shift and something won't go as planned. And so what happens then? Well, optimization models and any rules or set of logic as we know it are built off a deterministic state of the world. A data scientist attempts to represent the ideal state of the world in logic. But what happens when the rules that I encoded a year ago, a month ago, a day ago, no longer reflect the current moment, the current state of the world? I, as the operator, I'm forced to abandon any sort of optimization tooling and revert back to manual adjustments, because those manual adjustments have the safety of flexibility. So what we'll demonstrate today is the next frontier of optimization: AI optimization agents capable of advanced self-evolution to deploy the most optimal response to the constantly fluctuating challenges of my operations. Let's walk through an instance of AI optimization agents deployed in our production scheduling example. An alert appears from my machine disruption response agent. It's been evaluating the live streaming data from my machines, and it's determined that one of the machines has been disrupted. And that's impacting some of the scheduled jobs. Again, some version of this disruption happens in every type of planning operation. And so my job as a shop floor planner is to determine, how do I take this malformed state and reshuffle my operations around it in order to bring them back to an optimal operating state as determined by my original plan. So let's open the agent portal, and let's see what the agent has proposed. In my agent portal, on the right, I can see a list of specialized AI optimization agents who are each monitoring different aspects of my operation in real time. And on the left, I have a chat window with that machine disruption response agent. It informs me that it's actually already run the disruption response optimization model and has a proposed solution ready for my review. Let's highlight a bit what's happening here. That agent isn't just passively monitoring. It's actively analyzing the current state of the system. And based off of that real-time analysis, it's generating a tailored, actionable response. So instead of waiting for that human to detect, triage, and discover a solution, it's come up with all three instantaneously. And so as a result, I, as the operator, can actually start at the finish line, ready to evaluate and act on that recommendation. Now let's review that proposed solution. And again, I'm reviewing this in a simulation environment, so I can make tweaks or adjustments before I commit that back to my source system. And I can see that the jobs have successfully been reallocated away from that down machine. But there's still jobs being scheduled on machines that have planned maintenance. So let's address that. I'm going to ask the agent to add a new constraint to the optimization model that it's using. Schedule around downtime. The AI optimization agent will now evaluate my request. It's important to note that this agent has automation capabilities turned on. This means that the agent will determine whether it should take my request, build a new solution, and bring that back to me for review, or if it meets my automation criteria, automatically submit that solution on my behalf. Let's take a look under the hood at how the machine disruption response agent customizes the optimization model in response to my request. First, the agent starts by contextualizing my request. Using my business's ontology, how I've responded to similar disruptions in the past, and the current constraints that are available to the optimization model. Next, it evaluates multiple approaches and determines which is the most effective solution. And it generates that optimized schedule. And finally, the agent will determine if it should submit that automatically on my behalf if it meets my baseline criteria, or return that back to me. And in this scenario, we see that the agent has decided to automatically commit that optimized solution. So in just a few minutes, my agent simulated, it customized, it optimized, it automated a response to the disruption. Now imagine expanding from a single AI optimization agent to an entire fleet. Each one specialized, each one automating tailored optimization models for different issues across your operation. Traditionally, when a disruption occurs, the planner or the operator has to abandon any automated or recommendation tooling and manually intervene to get those operations back on track. And that's been because legacy algorithms or rules or optimization models, they weren't designed for indeterministic scenarios and unpredictable disruptions that happen in the real world. But with AI optimization agents, your operations planner can work side by side with an intelligent copilot. And with AI optimization agents, we have the optimization's ability to evolve. Thank you.